So this is finishing up 5.5. This was the last problem that we did. All right. So we're gonna finish. We're gonna do something. I want to do something else. Okay. Oh, dang! I lost my pen. I need my pen.
What color pen?
It's a black one.
Would you like mine?
I have to. No.
Is it right there?
Got a special one? Yes. Thank you. Okay. So here we go. So this was the problem that we did, right?
Yes.
We divided this polynomial by x minus 2.
Yes.
All right. Now, I want us to do it using synthetic division.
How will we do it?
Now, we've already done synthetic division. We actually called it synthetic substitution. You know why we called it that?
Why?
I'm not going to tell you. I'm going to see if you remember.
All
All right. So, we're going to divide this by this with synthetic substitution. So this was the one where you had the porch. You remember? Okay? And you had to look up here, and what did you have to make sure you had?
All power.
All powers. So 3, 2, 1, and 0. And y'all listen to me. It has to have the x to the 0, which is the constant. If it doesn't have a constant, you have to put a 0 in its place. I'm going to test you on that on the worksheet. It's going to be a whole bunch of kids, they're going to miss that one because they won't put a 0 right here. If it doesn't have a constant, you've got to put a 0 in its place.
Did we call it?
Okay? Then, we called it synthetic substitution.
Well, yeah, did we call it because we had to put in the
Yeah.
powers? Okay.
That's exactly right. Okay, so now we're going to write down its coefficients. 1, 5, negative 7, 2. 1, and leave a space. Leave one line on the porch, and he goes on the porch too. 1, 5, what goes next? Negative 7 and 2. Very good. Okay, out here goes a 2. If x minus 2 is the factor, what would the root be? 2. So he goes there. Are you with me?
Yes.
Okay, so now I'm just going to bring this 1 down. What is this right here?
Arrow.
Very good. So I have kids that sit in here for like weeks, and then I'll ask them, why don't you know how to do synthetic division? They're like, well, I don't know why you write that 11 with the thing on the bottom. Like, oh my gosh, please pay attention. If you don't know something, you just say something. It's an arrow, because you bring this guy down. And then you multiply. What's 1 times 2? And then you add. What's 5 and 2? What's 7 times 2? And then you add. What's negative 7 and 14? And then you multiply. What's 7 times 2? What's 2 and 14?
Oh. There's something.
You see any similarities?
Yeah.
Huh?
We have to do it.
Do you see any similarities?
Yeah.
What?
That's the same remainder you don't have to.
Okay, that's the same number that we got here as the remainder. So he got it as a remainder too. Any more?
Oh, they're all the coefficients.
Oh, these numbers right here are all these coefficients, okay? And this is a 3rd degree equation, and this is a 2nd degree equation. Guys, listen to me. If you divide an x to the 3rd by an x to the 1st, which is what we just did, what will you get? An x to the 2nd. Yeah, he'll be 1 degree less. So this is 1 degree less. He is 1 x to the 2nd plus 7 x to the 1st. He's just going down by 1. Plus 7, this guy's my remainder. So plus 16 over, this becomes x minus 2 again because I'm talking about polynomials and not just numbers, okay? Now, which one's easier? Yeah, synthetic division is a lot easier, but here's the thing. Guys, you can only use synthetic division if you're dividing by what we would call a linear binomial. That means it can have how many terms? 2, and the x has to be an x to the 1st. So all you can have is an x plus or minus something. That's the only time you can use synthetic division. Could I use synthetic division on this guy? No. So you have to learn long long division because synthetic division doesn't always work. Okay? So that's why we learned long division. But sometimes synthetic division works, and it is extremely cool. Okay? So first of all, let's just really quick write down some of those rules for synthetic division, just to make sure that we have them somewhere and we remember them. All right? So, what did we say about the powers?
Oh, you guys are all in.
Yeah, so all powers represented.
Polynomial and standard form?
Yes, they need to be in descending order. But look, I'm going to put here, and the reason I'm going to put this is because I've already told you, this is where the mistake comes in. Kids, they get all powers. They'll pop zeros in. But if there's not a constant at the end of it, they don't see that, okay? They don't think about, if it goes 4, 3, 2, 1, they're like, oh yeah, they're all there. People, okay? You must, so this means including an x to the 0. That is my constant. In this case, it is the 2, because that is a 2, x to the 0. Anything to the 0 power is 1. So 2 times 1 is just 2. That's why it's not there. Means I have how many x's? 0 x's. All right? And then, yes, they do. Lacey said they have to be in descending order. Okay? And then, what did I say out here? What is this guy? Yeah, he's the root. Okay? What's this guy right here?
The remainder.
Yeah, he's my remainder. This guy right here, he's my root. Okay? Let's talk about these guys. These are the coefficients of the answer, or I'm going to call it the quotient, because that's what it is. The answer when you divide is called the quotient, so I'm going to call it the quotient. You call it whatever you want to, guys. It's your notes. Make them where you understand them. Okay? How do I know what power to start at?
Can't you just count back from the bit? They go like that's gonna be more.
Yeah, that works, and the reason that works is only because you have to have zeros in missing places, okay? But I want to know why you should always know what this is without counting backwards.
I would take a guess.
Yeah, he's 1 degree less than your dividend, 1 degree less than what you started with, what you were dividing into. Why? Because you're dividing by next to the first. So he reduces him down 1. So 1 degree less than the dividend, who is in the house, right? Here he's on the porch, but. All right, and that would be what you started with. All right, is everybody okay so far? So this is what we're doing, guys. I mean, this is what we're doing all day today. We're doing synthetic division. Okay? We're doing synthetic division, and we're learning stuff about it. And we're learning what it means and how it can help us. All right, so here we go. Let me ask you this. Do y'all remember synthetic substitution? Synthetic substitution, what would I be substituting in this polynomial?
Nothing.
A 2.
What do you mean?
I would be taking, see when they told me this, I'm going to divide it by this. I'm going to substitute a 2. It would be equivalent to what you might call, we call them roots and factors is what we've been calling them, right? Okay, so this is like my factor, and then positive 2 would be my root. So, watch this. Let's plug a 2 in and watch what happens. What is 2 to the third? 8 plus, what's 2 squared?
4.
What's 4 times 5? So I got 8 and 20 make what? 28. What's 7 times 2?
14.
So what's 28 minus 14? What's 28 minus 14? 14. 14. And what's 14 plus 2?
Oh my god.
Do you see it?
Oh.
It's 16. That's why we called it synthetic substitution, because whenever you substitute this number in the polynomial, whatever the remainder is, that's what you would get if you plugged it in. Okay? That's what you would get if you plugged it in. Alright, so what's this called?
The remainder.
And you get it when you plug that guy in. Do you agree?
Yes.
Okay, so here we go. The remainder theorem.
Uh-oh. I don't like these.
Now listen, yesterday I told you we're going to talk about the remainder theorems and the factor theorems, and I said, gosh, you already know this. Okay, you just haven't really thought about it in this way. So here is the remainder theorem. Now, when I write the remainder theorem, I'm going to write it technically, like your book would write it. Is it important that you be able to read technical books?
Yes.
Yes, math and science books are written in technical language, okay? So in college, when your teacher doesn't teach you every day, okay, then you're expected to learn your own lessons, all right? So you need to learn how to read them. So here's what it says. If a polynomial, we'll call him f of x, is divided by x minus k, then the remainder is, now this big R, what's he stand for? Remainder is equal to f of what?
Okay.
K. That one was x minus 2, and we found out that the remainder was what I got when I plugged 2 in. When I did f of 2, it was 16. Okay? So, write this down. The same as when, probably not the best English, you plug k in. Alright? The same as when you plug k in. That's what the remainder theorem says. Alright? So, here we go. Example 3. Divide f of x is equal to 2x to the third plus x squared minus 8x plus 5 by x plus 3 using synthetic division. All right, should you be able to do this?
Yes.
Okay, so I'm going to give you a minute. All right, and I'm going to let you do it. You do it. At least get as far as you can get. Check those coefficients. I mean those exponents, not coefficients. What goes out here, guys? Negative 3. Very good. Now, is this my answer?
No.
No. Write your answer like it's supposed to be written. Write your answer like it's supposed to be written. All right, anybody got a question about this part up here? Okay, I brought my 2 down, I multiplied, I added, I multiplied, I added, I multiplied, I added, this is my remainder. This is the coefficient of my polynomial, all right? 1 degree less would be a 2x squared minus a 5x plus a 7, and then I have a remainder. So minus 16 over what? X plus 3. If you're writing polynomials, then remember to put that -3 back as a polynomial, okay? Now, here's my question. Is x plus 3 a factor of this guy?
If it is, that's gonna be really, like.
Okay, so let me ask you another question. You should know the answer to this one, okay? Is 2 a factor of 6?
Yes.
Why? He goes what? He goes into 6, what do y'all say? Evenly, okay? Y'all usually say evenly. What do you mean when you say evenly? Without a remainder. So 2 is a factor of 6 because when I divide 2 into 6, I don't get a remainder. What is my remainder if I don't get one? 0.
So it's not a factor.
Oh,
Wait, what? Good, because that, if it.
why is he not a factor?
Because
Because the remainder's not 0, people, okay? So is x plus 3 a factor?
No,
No. Why?
because it's
they have the remainder.
Yeah, our remainder's not equal to 0. In order for it to be a factor, y'all listen to me, is 5 a factor of 6? Why? It doesn't go in there evenly. That's what y'all say, right? And if I said, what do you mean by that? It doesn't go in there evenly. And you say, because you've got something left over, right? You got a 1 left over. So, if I don't have anything left over, if my remainder is 0, then you're saying that this guy right here is a factor of that polynomial. Okay? So, oh, that's what we're going to do. Okay? So, but before we do it, we're going to write the factor theorem.
More theorems?
Yeah, the factor theorem. Now, y'all listen to me. The factor theorem is going to say just exactly what we just got finished saying in our own little words. Okay? So, but he's going to say it technically. A polynomial, what are we going to call him? Yeah, we're going to call him f of x. Has a factor x minus k what is that? Have y'all ever seen that? Yeah. It means if and only if.
Oh, is that like?
It's a math thing, okay? It really came from actual set notation, proper set notation. All right, so, this polynomial f of x has a factor x minus k if and only if f of k, when you plug k in the polynomial, what should you get? What did you say? If you plug k in the polynomial, that's going to be my what?
Oh.
My remainder. And what should it be if it's a factor? 0. Very good. Okay? So this is just another way of saying your remainder will be 0. If it's not 0, it's not a factor. Okay? All right, so let's try a problem. Here we go, example 4. Anybody got a question?
No.
Is everybody okay?
Yep.
All right, so we kind of looked at it 2 different ways. We kind of looked at it with some little simple numbers that we know about, and then we looked at it with polynomials and what they meant and how they kind of go together. They have the same rules. All right, so factor, now this is telling me to factor something. This polynomial, f of x is equal to 3x to the third minus 4x squared minus 28x minus 16. Now, first of all, if you tell me to factor this, what's the first thing that comes to my mind? Yeah, he's got 4 terms, so I would go, oh, I gotta group this guy. So group these first 2, and what can you take out? An x squared. What are you left with? 3x minus 4? Can you take something out of this to be left with 3x minus 4? People, what do you multiply by 3 to get 28? Yeah, nothing, okay? You can't get a 3x minus 4. So can you factor this?
No.
No, all right? But what if I give you one of the factors? What if I say x plus 2 is a factor? Now think about this, okay? Can I use synthetic division with this x plus 2 and take this cubic down to a what?
Square.
And can you factor squares?
Yes.
All right, so let's try that, okay? So, what do I check first? I'm checking exponents, guys. 3, 2, 1, 0. And then I'm writing my coefficients down. 3, negative 4, negative 28, and negative 16. Now, do I know what this remainder is supposed to be?
Yes.
People, they said it was a factor. What's your remainder?
0.
0. All right, this morning I wrote this down wrong. And so when the kids all did it, they were like looking at me, and I started doing it, and I was like, whoa, 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 we got a problem. Okay, because I knew I was supposed to have a 0 right here. What goes out here?
Negative 2.
Negative 2. Very good. All right, you do it really quick. All right, so what is this polynomial? What'd y'all get?
3x squared minus 10x minus 8.
Very good. 3x squared minus 10x minus 8. Can you factor it? Factor it for me. You ought to be able to do that. Did you get it? Okay, so 3x squared factors into 3x and x. I know they have unlike signs, and the factors of 8 are 1 and 8 and 2 and 4. 4 times 3 is 12, and 2 times 1 is 2, so I need to subtract those. So, pardon me. So I want a negative 12, so I'll put my negative 4 there, and my positive 2 here, right? I'll check my inners, plus 2x, my outers, negative 12x, there's my negative 10x. So completely factored, I have 3x plus 2 times x minus 4 times x plus 2. Don't leave that guy off. That is completely factored. All right, anybody got a question? Okay, so here we go. Next one. Example 5. F of x is equal to x to the third minus 5x squared minus 12x plus 36. Okay? How many answers does he have, guys? 3. Y'all, that's one of your questions on your 50-point test. Okay? I think if you can't do that, you haven't been paying attention for the last 2 weeks. So, if x is equal to 2, find all other zeros. What else could I have called them? Roots. What else?
Solutions.
Solutions. Answers. X-intercepts. Okay? So, what are we going to do? Yeah, we're going to do synthetic synthetic division, and we're gonna use this too, because he is a root, guys. He's a 0. And we're gonna divide this down to a quadratic. Hopefully I can factor it and solve it. So, 3, 2, 1, 0. They're all there. There will come a time when they're gonna make you have to put something in there. What am I dividing by?
2.
Mm-hmm. Shall I get x squared minus 3x minus 18?
Yes.
Okay.
Does anybody have whiteout?
Huh?
Does anybody have whiteout?
Here, I do.
And it's a whole thing.
Good catch. All right, plus and minus. Subtract to be 3 would be 6 and 3, and I want a negative, so I put my 6 there, my 3 there. So what is this root?
X equals 6.
Mm-hmm. And what's this one?
Negative 3.
Y'all, that's all the way back from chapter 4, isn't it? Okay? So, 6 and negative 3 are my other answers. Anybody got a question?
No.
Okay, so right now, you must be able to do these 3 things, okay? Thank you. You must be able to, given one factor of a polynomial, find all others. Have we done that?
Yes.
That was example 4, wasn't it? Okay? What about this? Given 1, 0 of a polynomial, well, what if that thing hadn't a factor?
You left like that?
Could I find them?
Yes.
How?
Quadratic formula.
Oh,
Oh, yeah.
quadratic formula. That's pretty cool. 1, 0 of a polynomial. Find the other zeros. All right, that was example 5. All right, here's one more. Given one solution of a polynomial, find the other solutions. What do you think about that one?
Example.
Example 5.
Yeah, it's just like this one, isn't it?
Yeah.
But it's actually gonna be example 6. Okay? Now, nope, we're fixing to do it right now. And I'm gonna tell you this, you're gonna hate. You're gonna be mad at me, all right? So, might as well just get over it right now. Example 6 is an amazing problem, okay? An amazing problem, but it's a lot of writing. So, sorry, don't feel bad before you go, because this, I have to write it down all the time, all right? So, here we go, example 6, just keep copying, okay? The profit P, and that's profit like money, not profit like someone who prophesies. That's what the other kids wrote down, I was like, what? The profit P in millions of dollars. So, big company, right? The profit P in millions of dollars for a shoe manufacturer. modeled by, can be modeled by, P is equal to negative 21 x to the third plus 46x, where x is the number of shoes produced in millions. The company now produces 1 million shoes. And makes a profit of $25 million. But would like to cut back on production.
Never a good thing. Are they trying to do
All
less
right.
and make more?
So listen to this. What lesser I'm having a hard time writing that word, I don't know. What lesser number of shoes could they produce and still make the same profit? Okay, so they're asking, can I make lesser shoes and still make my $25 million? Does that seem possible?
Yeah, I just don't like this because they're really gonna increase make
That's pretty cool, y'all. Look, I mean, if this was your business, wouldn't you be like going, what? I can make lesser number of shoes and still make the same amount of money, all right? What am I cutting? What could I be cutting?
quality.
Oh, no, we're not cutting quality, and we're not raising the price either. We're not cutting quality and we're not raising the price. But what about the equipment? Is the equipment have to work harder to produce 1 million shoes as opposed to lesser number? When the equipment works, do I have to keep it fixed and running? Does that cost money? You probably have a whole team of people. The maintenance people, right? They're called all the time.
So we're cutting
I'll buy
jobs.
less materials, so that'll save me some money. I might even cut some jobs,
I
okay?
don't like this company. It's not
and-
right there.
So we're gonna see if we can do this. All right, so somebody tell me what the equation for the profit is.
P equals negative 21 x cubed plus 46.
Very good. All right, and what did they tell me my profit was?
And millions.
25 million,
Million.
right? 25 million? Okay, so what do I put in for P?
25. I don't know.
Scientific notation.
25.
Yeah, 25. 25, because if you put in 25 million, you're saying that you're making 25 million, okay?
That's a
No,
lot.
that's 12 zeros, people, not 6.
That's a
Okay,
lot.
so 25 is equal to negative 21 x to the third plus 46x. So actually what I'm trying to do is solve this equation for x. Do you agree with that? Because x is the number of shoes. All right, to solve it, what do I need to set it equal to?
0.
0. Okay, so I'll pull that little 25 over there, subtract 10 from both sides. And then he'll look like this. Okay? So I'm trying to solve this cubic equation, but he doesn't factor, okay? So, let's see, we've been using, what about, do I have a solution? Do I have a number that will give me 25 million? Yeah, they said I produce 1 million shoes and make a profit of $25 million. So that 1 million is a solution, okay? So I'm going to use that solution and take this cubic down to a quadratic, and then I can solve it. If it factors or it doesn't, I can still solve it, okay? So here we go. Synthetic division. What goes on the outside?
Negative 1.
One,
I meant 1.
just one. My 1 million, okay?
Oh, good, that's a solution.
What about right here? What goes right here?
Negative 21.
Uh-huh,
0.
0. You don't have an x squared, you gotta put it in there.
46.
46,
Negative 25.
negative
Can
25.
I follow the white out? I would like to let you agree. Even though I
So-
said it. I'm not a good
That's
teacher.
okay. Throw it to next time. All right, so now I'm going to bring down my negative 21. Gonna multiply, negative 21 times 1 is negative 21. I'm gonna add negative 21. I'm gonna multiply, negative 21. I'm gonna add 25, multiply, 25, and add, and 0. We knew this was a 0 because we already said he was a solution. So this is my quadratic, negative 21 x squared minus 21x plus 25. Are you with me?
Yes.
People, he doesn't factor. Okay, so we're gonna use the quadratic formula. So x is equal to, now guys, listen to me. If I could tell you anything about the quadratic formula, do not poke it all in your calculator at one time.
Oh.
Okay, you will most certainly make some kind of stupid mistake. All right, so it is negative b.
Plus or minus.
What is this? What is this? What's negative b?
Negative 21.
Positive 21.
Oh.
Plus or minus the square root. Now that I will do on my calculator, okay? So I'm just gonna take my little calculator here, all right? And I'm going to go b squared. Now look, whenever I square this negative 21, I'm not putting the negative sign on it, because I know when you square a negative, it's not gonna be negative, it's positive, okay? So I'll go 21 squared minus 4 times, what's a?
Negative 21.
Negative 21 times c, what's c? 25. Okay, so this is the number that goes under the radical. 2, 5, 4, 1. All over, thank you.
This number.
2 times a, which is negative 21. Okay, so I got 2 answers here. Do you agree? Yes? Okay, so I'm just gonna find them one at a time, but I am gonna do it on my calculator. Okay? I could use a fraction, but I'm not a big fraction button person, so I'm not going to. So I'm gonna say 21 plus the square root, and I'm gonna go up here and grab this number and pull him down there. Now, I need to divide by negative 42, but I need to divide the whole thing by negative 42, so I'll press the enter button, make him find the answer, and then I will divide by negative 42. So one of my solutions is negative 1.7.
That's not possible.
Why is that not possible?
That's negative.
Yeah,
Well,
you
look, it
can't
was
make
seed shoes
negative.
and make money, that'd be
Yeah.
awesome.
Yeah, you can't make negative number of shoes. So yes, he's out. He is an answer to this equation, but he doesn't make sense in my problem. All right, so let's do the other one. I'm gonna go up here, I'm gonna grab this guy and push back here and change that plus to a minus. Then I get this number, I'll divide him by negative 40, oh, stop. Negative 42, okay? And then I'll get 0.7. Now that could be an answer, do you agree? So tell me, don't say 0.7, please. How many shoes do I have to make to still make my $25 million, but they're less than $1 million? 700,000 shoes, and you will still make your $25 million. That is cool.
But at
Do
what
you think
cost?
if you went to your boss and you told him that, first he might be skeptical, right? But yeah, you're cutting some costs.
What's the cost for it though?
Materials, employees.
Materials, could be. It might not be employees. It might be that you want to take those employees and maybe open up a store to do something. You see what I'm saying? So it might not be employees, but
Materials,
He's
maintenance.
gonna be like, oh, that's a good idea, you're fired.
Inspection.
I doubt he's going to do that. Okay,